Okay, this is conditional probability in the general multiplication rule. It's the conditional probability plus part section of your homework. This is just really focusing on rule 2 that I gave you, where you have two events and they're dependent of each other, and you're trying to find the probability of E and F. And remember, I told you it's the probability of E times the probability of F given that E already happened. Okay, so for example, let's say I wanted to find the probability of choosing 2 queens in a deck of cards in a row. And this is without replacement, so I'm not going to put the queen back once I receive a queen. Okay, so let's think about that a little bit. These are dependent events because the probability of me choosing a queen on the second pull is affected by pulling a queen on the first. So think about this. 52 cards in the deck. I want to pull a queen. Well, how many queens are in the deck? There's 4 queens out of 52. Okay? Now I have my queen. I have my queen in my hand, and I'm not going to put it back, so it's without replacement. What's the probability of me getting another queen? Well, how many queens are in the deck now? There's 3. Out of how many total? Now there's only 51 cards. So this is the probability given that the first queen was already chosen. So now to figure out the probability, with fractions you multiply straight across. So 4 times 3 is 12. 52 times 51 is 2652. And then this reduces to 1 out of 221. So I have a 1 out of 221 chance that I would choose 2 queens in a row given that I didn't put the first queen back when I drew it. So that's how you do it. You just have to take in consideration with your probabilities that the first one already took place. Okay, so let's try a couple more problems. Okay, so let's take a look at this problem. In January in a certain city, 51% of the days are cloudy. Also, in the month of January in the same city, 19% of days are cloudy and snowy. So what is the probability that it's snowy if it's cloudy? Okay, so what's really, really important here is you have to know what it's asking. Does this right here say I want the probability that it's snowy and cloudy? And the answer is no, that's not what it's saying. I already know it's cloudy. It says the probability of snowy if it's cloudy. So I already know it's cloudy, I just want the probability it's snowing. So you're looking for this, the probability of it being snowy given that it's cloudy, which is totally different from this. Okay, so it's just really important that you read through and see what you're trying to find. So all you would do here is to take the probability of it being snowy and cloudy and divide it by the probability of it being cloudy. Now you're thinking, Miss Seeley, I'm sorry, this doesn't go there. This equals that. So you're thinking, Miss Seeley, how did you even get that equation? Well, you guys, y'all have to learn how to manipulate equations. For example, and this is just like a little side note, everyone's pretty familiar with Pythagorean theorem. A squared plus b squared equals c squared. With trying to find the sides of a triangle, of a right triangle. So if I give you 2 sides of a triangle, you'd be able to find the longest side of the triangle called the hypotenuse. But what if I gave you a hypotenuse and a side? Could you find the other side of the triangle? And the answer is yes. You would just have to manipulate the equation. Well, I told you that a probability of E and F happening equals the probability of E times the probability of F given E already happened. Well, then if I'm looking at this, if I'm looking for this, wouldn't I just divide both sides by P of E? And that would be gone, and so that's what I'm looking for. So since that's what I'm looking for here, the probability of it snowing given that it's cloudy, I would just take the probability of being snowy and cloudy, which I know that's 0.19, and divide it by the probability of being cloudy, which is 0.51. And I get 0.373. So there's a 0.373 chance that it is snowy given that I know that it's cloudy. So it's really important to know what the question is asking and which part of the equation that you're looking for. Let's try another problem. Okay, suppose you Suppose you receive a shipment of 6 TVs. 2 of them are defective. If 2 TVs are selected at random, what is the probability that they both work? What is the probability that at least one does not work? Okay, so just a little scenario. I get 6 TVs. I know 2 of them are defective, but I don't know which ones. So then I choose 2 TVs at random. What's the probability of them both working? Okay, so let's take it one at a time. We're just doing this one. The probability that they both work. Well, if all 6 are lined up, how many of them work? I know for sure that 4 of them work. Out of how many TVs total? 6. So then I grab a TV, I know it works, I had a 4 out of 6 chance of it working. So then I'm not going to put that TV back. I have it there on the table. Now, what's the probability of me choosing a TV that works? Well, now there's only 3 TVs that work in the stack, and there's only 5 TVs total. Okay? And so that's what you do. You just take the probability of 1, given that the first one already happened. So then, let me reduce this. This become 2/3 times 3/5. The 3's cancel. 2/5. I have a 2/5 chance of picking a TV if I pick 2 TVs that both of them work. Okay? Now, I want to look at the probability that at least one does not work. Now, let's think about all of the scenarios, okay, of me picking 2 TVs. The first one could work, the second one could work. The first one could be defective, the second one could work. The first one could work, the second one could be defective. Or they both could be defective. Do y'all agree with that? And so if I want to find the probability that at least one does not work, couldn't I find the probability of this happening, and this happening, and putting them together? Because those are all the ways that one of them could not work. Or I could just do 1 minus the probability of them both working. Because we know that this right here has to equal 100% if those are all of the scenarios. So I could just take the complement, 1 minus the probability of them both working, which we already found. So I know I could just do 1 minus 2/5, which is 3/5, and that's the probability of at least one of them not working. Okay, what if I had asked, let me erase some. Ooh, I don't want to erase that. Let me erase this part over here. Let me fill this back in. This was work. This right here was 3/5 is my answer? Okay. What if I had asked, what is the probability that at least one works? Before I did at least one does not work, what if I asked you the probability that at least one of them works? So then the scenario would be that I could have this one, and this one, because that's all 3 scenarios where at least one of them works. So you can find all of those and put them together, or you can do 1 minus the probability that they both do not work. Okay? So I'm going to come over here and just find the probability that they both don't work. Well, just out of the first, so I have 6 TVs again. They're all lined up together. What's the probability of me choosing one that does not work? Well, I know there's 2 in there that are defective out of the 6. So then I grab one, and it is defective. So now what's the probability of me getting the other defective one? Now there's only 1 that's defective out of 5. Okay? So, multiplying straight across, you get 2 out of 30, which is 1 out of 15. Okay? So that's the probability of me getting 2 in a row that are defective. But I'm looking for the probability that at least one of them works. And so what I did is just get the complement. I'm doing 1 minus the probability that both of them don't work, which is 1 minus 1/15, which would give me 14/15. And that would be the answer to the probability at least one of them working. Okay, well, hopefully there's a better understanding. Go ahead and try some of your homework problems and let me know if you have any questions.